Hi, I'm Terry Klinker. We're going to continue with our discussion of decision analysis today. This is our second video on indifference points. In the first one, I showed you a very simple case. We had two options, and we went ahead and built the indifference table and solved for it. We're going to do the same thing today. I'm going to use three options and show you the difference in how to build the table. Obviously, the more options you have, the more complex it becomes, because you have an indifference point in between each of your options. It's not just between option A and B. It would be between options A and B, A and C, and B and C. If you had four options, it would be between A and B, A and C, A and D, B and C, B and D, and C and D. So the more options you have, you get exponentially more problems that you have to solve to figure out where you are. So we're going to use this one to kind of show you how it gets a little bit more complex with more options. Our problem today is you're a purchasing manager. Engineering has updated the design of your product, and you have to go out and find a supplier for some of the new supplies that they need. For one of the parts, you've identified three vendors, and in my typical ingenious way, I've labeled them vendors A, B, and C. A, B, and C have given you different cost structures. Vendor A is going to charge you $1,000 setup every time you order. Then they're going to charge you $10 for every part. Vendor B is going to charge you $10,000 to set up. Breaking into their operational running time is much more expensive, but they only charge you $1 for every unit that you purchase. Vendor C charges $5,000 for a setup, and they charge you $5 for every unit you purchase. So, what do we need to do here? First off, what are we trying to do? All right? To solve problems, you need to do three things. What am I trying to solve for? What tools do I need for it? And what data do I need to solve for those tools? Alternatively, in this case, we know what data we have, and we know what we're trying to solve for, so we have to go back through and establish what tools we're digging out. In this case, we're trying to find out which costs the least. Now, in the last one, we were trying to find maximum profit. You can only calculate profit if you know what the price is that you're going to charge for something. In this case, we're only looking at cost. And if you remember correctly from one of the earlier videos, our total cost is going to equal your fixed costs plus your variable costs. And your variable cost was a function of quantity. It was going to be that variable rate times the quantity, X, that you actually purchased. So if we come over here, we're going to do our total cost. I've broken it down into a table. I've extracted the data from the problem. Vendor A has a fixed cost of $1,000 and a variable cost of $10 per unit. So our total cost for vendor A is going to be $1,000 to set it up plus $10 times however many we purchase. B had a $10,000 setup, $1 per unit, so our total cost for vendor B is going to be $10,000 plus 1x, or just x. This is something actually that will throw you off in my class, and I'm not sure why, or in any quantitative function. When I quit putting the coefficient in front of x, somehow you start to forget that that's an automatic 1. Yeah, I know not all of you will do that, but some of you do. That's why I bring it up here. Vendor C, $5,000 to set up and $5 per unit, so my total cost for vendor C is going to be $5,000 plus 5x. So we start out with our base problem. We take our base problem and extract the data we need from it. These blue numbers here were the data we needed. After that, we come up with a function. We try to convey each thing into a function. We convert the word problem into functions, and that's what I've done here. I found out what the total cost of each one is. Once we do this, we need to find out where the indifference points are. The indifference points, again, are where we are indifferent as to whether we choose vendors A, B, B, C, or AC. Now, you can only have indifference points between two options. Don't try to figure out where total cost of A, B, and C are all equal. Because in all likelihood, it's either an infeasible solution where there is none, or it's some number that's not possible. some negative number somewhere in space. Remember, you can't make a negative quantity of something. You can't purchase a negative quantity of something. Your variables must be greater than or equal to 0. So here we have three indifference points. We have an indifference point where the total cost of A equals the total cost of B. We have it where the total cost of A equals the total cost of C. And we have one where the total cost of B equals the total cost of C. Now, like last time, we're going to stick these equations that we came up with into this and then solve for x. Total cost for A was $1,000 plus 10x. Total cost for B was $10,000 plus x. Do a little bit of algebra here. We end up with 9x equals $9,000. My indifference point here is at 1,000 units. At 1,000 units, the total cost for A equals the total cost of B. We don't care which decision we make. If we expect to purchase 1,000 units, we can go with either of these vendors. Come down here and calculate A and C. A is again 1,000 plus 10x. C is 5,000 plus 5x. Do a little bit of math here, and we end up with 5x equals 4,000. X in this case equals 800 units. Same thing for B and C. B is again $5,000 plus 5 times the quantity. C is $10,000 plus 1 times the quantity. Go through and do some math here. We end up with 4x equals 5,000. X equals 1,250 units. What we've done now is we have identified all of our indifference points. We have indifference points at 800, 1,000, and 1,250. Well, that's great. We know where the quantities, where the total cost is the same. What we don't know is which would we choose between those quantities. So just like we did last time, we're going to build an indifference table. And we start out with the indifference points. All right, so let's put the indifference points in here. My indifference points, and you want to put them in increasing numerical value. So in this case, the lowest one I have is at 800, 1,000, and 1,250. Now once again, we know that we will not be able to make a definitive decision between any of these at those points. So we don't want to evaluate it at 800, 1,000, or 1,250. What we want to do then is come up with a test point. And as we did last time, our test point will be between the two numbers. Now I can use any number between 800 and 1,000. I could use 801. I could use 9999. I always try to pick the one that's going to be the easiest to calculate. In this case, between 800 and 1,000, I used 900. Between 1,000 and 1,250, I chose 1,100. Now we come back to 800 to negative infinity. Well, we know it doesn't go to a negative infinity. It can only go to 0, because once again, I can't make a negative quantity. I can't purchase a negative quantity. The easiest way to calculate, the easiest number to stick into this equation would be to use 0. If you have a hard time using 0, pick 500 or 100, whatever makes you happy. I always use 0. It's easy to use. 1,250 to infinity. As I said last time, never choose infinity. Makes the calculation much more complex. In this case, I'll just stick with 2,000. Now, it doesn't matter if I choose 2,000, 10,000, 100,000. I'm going to get the same answer. Before I go a whole lot further, come back and take a look at this. If the quantity you were going to purchase was 0, which would be the best option? Now, most of you can take a look at this and say the best option, if I, first off, let's assume I would put an order in if I'm ordering 0. Just pretend with me for a moment. which one would you use? Well, the cheapest one would obviously be A, because it cost me $1,000 to set it up to get nothing. 10,000, 5,000, this is the cheapest. If I was going to order infinity, well, I can't order infinity. If I was going to order 1,000,000 units, which of these options would you pick? Again, the option would be B, because this $10,000 setup cost is easily dwarfed when I only have to pay $1 per unit times 1,000,000 units. It's going to be a lot cheaper. So you can look at the extremes and figure it out. Since somewhere between 0 and 1,000,000, we changed from choosing supplier A or supplier B, there is an indifference point in there somewhere. We had established these indifference points. Now we're going to find out for each gap in here which option we would do. So let's go back over here. We've got our test points. Now we're going to find out what's the total cost for A, the total cost for B, and the total cost for C for each of these options. And in this case, all we have to do is stick the test points into our original equations to come up with those numbers. So for A, I stick 0 into this equation. 1,000 plus 10 times 0 is $1,000. 10,000 plus 0 is $10,000. 5,000 plus 5 times 0 is $5,000. For 900, 1,000 plus 10 times 900, 10 times 900 is 9,000. 9,000 plus 1,000, it would cost me $10,000 if I ordered 900 units. 10,000 plus 1 times 900 is $10,900. Five times 900 is 4,500, plus 5,000 is $9,500. $1,100. 1,000, 10 times 1,100 is 11,000. 11,000 plus 1,000, it would cost me 12,000 from vendor A. $1,000 plus 1,100, 11,100 from vendor B. Five times 1,100 is 5,500 plus 5,000 is 10,500 from vendor C. Our last test point, 2,000. 2,000 times 10 is 20,000, plus 1,000 is $21,000. $10,000 plus 2,000 is $12,000 from vendor B. 2,000 times 5 is $10,000, plus 5,000 is going to be $15,000 from vendor C. So we've built our indifference table. We took our indifference points, found a test point between each of our indifference points, found out what the total cost of each option is at those test points. The last thing we do is identify the optimal solution, the optimal decision. Again, this is decision modeling. We've built a model. As simple as this looks, it is a model. All right? Between 0 and 800, my cheapest cost is vendor A. 1,000 is less than 5,000 or 10,000. Between 800 and 1,000, my cheapest is vendor C. 9,500 is my cheapest option here. Between 1,000 and 1,250, vendor C remains the cheapest option. Above 1,250, my cheapest option is vendor B. I have now built a model. As the purchasing agent, depending on what engineering or production asks for, what quantity they want me to order, I know which vendor to go to. If the quantity is between 0 and 800, I go with vendor A. If the quantity is between 800 and 1,000, I go with vendor C. If it's between 1,000 and 1,250, I go with vendor C. And if the quantity is greater than 1,250, I would go with vendor B. Now, I can actually simplify this further. I don't need both of these. Between 800 and 1,250, it's always C. So I could just make it 1,250 to 800 is vendor C. We've now built the complete table. What were my 6 steps? 6 steps were take the basic problem and extract the data. Second step is to develop linear equations to reflect the data. What kind of data you need. I needed to find out total cost. I took what I had and converted that into an equation. Third step, find your indifference points. Fourth step, construct your indifference table. Fifth step, identify the best option for each test point. The last step is build your model. Build your decision model. We'll work on more decision-making techniques in the next videos.